Now you should know this biology, okay? And you should be able to write it down. You should be able to discuss this biology, because that's the biology, okay? Yes. So now the adrenal glands, they are just adjacent to your kidneys. If you remember the other time, if these are your kidneys, the bean-shaped organs in your body, they are just here, the adrenal glands, and there are two of them, okay? They are just here. Now these adrenal glands, they are made up of two glands actually. It's two in one, where you have the adrenal cortex, okay, and the adrenal medulla. Now all these two compartments, they do perform different functions. And by the way, when you are describing how epinephrine or adrenaline is going to impact, and they just say adrenaline is produced by adrenal glands, that one is not biology, because not the whole of it secretes adrenaline, okay? It is a given compartment, the adrenal medulla, that is responsible in secretion of adrenaline, epinephrine, okay? Then the adrenal cortex is also responsible in secreting other hormones, okay? As you are going to see, the cortisol, the mineral the glucocorticoids, and we are going to see them. So if you just say the adrenal glands, then we shall not understand, okay? And so if we are marking, then marking is going to stop there. If it is paper 2, in the morning I was telling form 5s that paper 2, it is open-ended. You write as much as you can. So if you just tell us adrenal glands, then marking is going to stop there. We shall ask you which part of adrenal gland, okay? So you need to know these two compartments, the adrenal medulla and the adrenal cortex, okay? Now, the adrenal medulla, it secretes, let me first clean this. So adrenal medulla, it secretes epinephrine and neuroepinephrine. Now, all these two hormones, they are secreted in periods of stress, okay? Now, they are classes of catecholamines. Now, if this is a big term, just they are classes, they are amine derivative hormones, okay? Oh, sorry, if you remember our classes of hormones, we saw the peptide hormones, the amine derivative hormones, then we saw the steroid hormones and the fatty acid hormones. So now these ones, this epinephrine and the norepinephrine, they are amine derivative hormones, okay? So if this one is hard, they are amine hormones. Now, these hormones, they are secreted in response to stress, okay? And the adrenal medulla is going to be activated by an impulse from the hypothalamus or from the nervous system, okay? And so when they are secreted, they mediate the flight or fight responses. You either combat or you run away if you can't manage, okay? And a good example is, imagine where you are seated there, boom, you see a snake in your legs. How are you going to respond? Do you just stand up and move majestically? Of course no. You don't even know how you're going to take off from there. So now, the hormone that is responsible for that response, it is epinephrine, or it is epinephrine is the same as adrenaline. Actually, for those, epinephrine is the same as adrenaline, okay? Sorry for that. So it is adrenaline, okay? So now you should be asking yourself that, How is it able to do that? Which physiological changes is it going to cause in your body to bring about such a response? So now these hormones, they prepare your body to respond to a stressing condition. Okay? Now we are going to see. Now, how are they? Number one, for you to respond in such a rapid manner, then you must be able to have a robust of energy production. You produce too much energy that is going to bring about such a response. Okay? And so this hormone, therefore, that's why we say that it works in conjunction with thyroxine hormone, if you remember the effects of thyroxine hormone. So it is going to increase the rate of metabolism, okay? So that, yes, you produce a robust of energy to bring about the muscular contraction to either take off or fight. Number two, the heart muscles have the adrenaline receptors, okay? And so this adrenaline can also regulate the rate at which the heart is going to beat. So when it binds, it is transported to the heart, binds to the receptors to increase the rate at which the heart is going to beat. Now, why do you need to increase the heartbeat? So that you supply, first of all, enough oxygen, two, enough glucose to these muscles that are going to respond so that they respire, okay, to bring about the response. In other words, you are preparing yourself to either combat or you take off. Number three, this adrenaline is going to increase the rate of ventilation, the ventilation rate. So the rate at which you're going to breathe is going to be high. You can imagine. After taking off, you can imagine the way you'll be breathing. So high. Okay? So all of those are effects of adrenaline. Now, when we were young, we were told that when you see a snake, that you bite this now this shortest finger. I don't know how to name. Is it the index finger? I don't know how to name fingers in English. But the shortest one, the smallest one on the other extreme end. That when you bite that and you step on the same cuffing on the leg, that the snake won't be able to bite you. That it will be able to stay in that position. And we shall find it and kill it. Yes, I think you know what I'm talking about. Now, you as a science student, which possible explanation can you give? How can you explain the grandma, the daddy, who doesn't know that? Actually, the science is simple. That one works. It actually works. And how does it work? When you stay calm, okay? When you bite your finger and you step on the other finger, it means you are staying calm. And when you stay calm, then your body won't produce too much. There won't be a shunt of this hormone, adrenaline or epinephrine. Now, if you have ever seen a snake, as a snake is moving, the snake has a tongue which is branched into two. So it keeps on, there is a way it keeps on. Now I don't know how to illustrate, but if it keeps on, these two tongues, they keep on shaking, okay? Now with the two tongues, this one responds from this direction, and also this one responds to this direction, so that it knows, okay, where the chemical is coming from. And which chemical? Is epinephrine. Snakes are unable to see. Okay, they see, but they see blurred images. Okay? Blurred images that it cannot easily see that this is an enemy. But it has that high sense, and it senses adrenaline. So when you secrete too much adrenaline, then adrenaline is going to saturate in that air. Okay? And so the adrenaline receptors on this tongue, okay, there will be the adrenaline, it is going to attach on the receptors, receive it, and the snake is able to know that there is an enemy. The enemy is either taking off, or the enemy is either coming to fight. And so it either responds by taking off, or it prepares itself. If it's a cobra, the African black mamba, then that's when it will form this. You see it as ready to attack. Okay? But when you calm down, then the epinephrine won't saturate in that environment. Okay? And so if it won't saturate, then this snake won't be able to detect that epinephrine, and so it also stay calm. And if it stays calm, then you'll be able to find it, and either you are safe, or it goes, and yeah, you're safe. So that is the adrenal medulla. Now with the adrenal cortex, okay, this is the other segment, the other compartment of adrenaline. Now it also secretes hormone, and the hormone secretes by the adrenal cortex, they also respond to stress. But now the stress here is different from the stress of adrenaline. So hormones from adrenal cortex also functions in the body's response to stress. Okay? And these hormones, they fall into three classes of steroid hormones. Now you agree with me. These ones, they are steroid hormones. Okay? They are fat soluble hormones. And the first class, they are the glucocorticoids. Gluco comes from glucose. Okay? Such as cortisol. So these glucocorticoids, they are responsible in glucose metabolism. Okay? And they also do activate the immune system. So in other words, these ones, they work in conjunction with the insulin. Okay? In restoring, in regulation of glucose levels in your blood. Then we have the mineral corticoids. These ones. Mineral comes from mineral salts, minerals, the inorganic ions. Okay? Such as aldosterone. This one. Okay? Now this one, it affects the balance of sodium ions in blood, as we are going to see, and regulation of blood volumes. We are going to see it, okay? Just keep the hyper high, keep the hyper active. Then you also have the sex hormones, okay? Such as estradiol, estrogen, and progesterone. Now those sex hormones, however, the adrenal cortex does not produce, okay, in high quantities. There is overproduction of these sex hormones at puberty. But before puberty, it is this adrenal cortex that is responsible in production of these sex hormones. But now after puberty, now you produce FSH, the follicle stimulating hormone, which has an effect on the Leydig cells in males, and that FSH will stimulate the Leydig cells to release a high increase of progesterone hormone, okay, which will bring about the secondary sexual characteristics, as we are going to see. Then in females, the FSH affects the ovaries, okay, and so these ovaries will produce estrogen, and the estrogen will bring about the effects, as we are going to see. Okay, now how do they respond to stress? The concept is simple. There must be a stimulus, and in this case the stimulus is stress. Maybe which stress? It could be sight of a snake, maybe it could be increasing levels of sodium ions, or decreasing levels of calcium ions, depending on the stress. But now if the stress is a snake, then the eyes will see a snake, of course. Then the eyes will transduce the stimulus into an impulse that is transported to the hypothalamus. And so the hypothalamus is going to respond by sending an impulse through the spinal cord, the central nervous system, okay, the spinal cord, to the adrenal medulla of the adrenal gland. You have to be specific, adrenal medulla. Now this impulse, it will stimulate the adrenal medulla to release epinephrine or adrenaline, okay? And so a high increase in epinephrine, it will bring about a short-term response to stress, okay? And the response include, number one, glycogen breakdown. Why are you breaking down glycogen? To increase the glucose levels, okay? And so when you increase the glucose levels, which pen, let me use this. And so when you increase the glucose levels, then you have glucose, okay, to respire, to produce energy, because you need a robust of energy, okay? So you have to have glucose so that you respire the glucose, okay, to produce enough energy, okay, and the energy used to respond to such a stressing condition. If it's a snake, you take off. You increase blood pressure, okay? How? Why are you increasing blood pressure? So that you supply you supply this, the heart moves at a faster rate, okay? So that you supply the glucose and the oxygen at a high rate to meet the energy demands, so that you respond accordingly. Breathing rate, same thing, I talked about this, metabolic rate. Then change in blood flow patterns, leading to increased alertness and decreased digestive and kidney activity. For example, when you want to respond to a stressing condition, why should you channel blood to the digestive system? Why? Why should you channel blood to the kidney? Do you want to excrete? Why? So this epinephrine, it is going to cause constriction of certain blood vessels that supply organs that are not relevant in this case, and then increases dilation of organs that are relevant in this case, okay? So that's, and as a result, you increase blood supply. Somebody wants to be admitted, you increase the blood supply to these relevant organs, and so if you increase blood supply, you increase the response. Then for the long-term effects, that is in the adrenal cortex, this one is also responsible for responding to stress. Maybe if there is an increase in blood volume, as we are going to see in the next level, okay, then the hypothalamus will detect, then it stimulates the release, or it releases a releasing hormone, and the releasing hormone has an effect on the anterior pituitary gland, and so the anterior pituitary gland will release adrenocorticotropin hormone, no, tropin hormone, and this hormone has an effect on the adrenal cortex. Now, depending on the stress, it will determine what is going to be produced. If the stress is the mineral ions, for example, sodium ions, then you release the mineral corticoids. If the stress is glucose levels, then you release the glucocorticoids, cortisol, okay? And so these ones will respond by increasing the sodium ions. And so if you increase the sodium ions, then the blood pressure is going to be restored back to normal, okay? If the stress is glucose, if you don't have enough glucose, then these glucocorticoids, they will increase protein and fat metabolism to form glucose. You can call it gluconeogenesis, okay? And so this glucose, if you increase glucose levels, then you retain the glucose levels. Then they also activate the immune system depending on the challenge, depending on the stress, okay? It will determine. So literally, that is a brief summary. So let me admit this person, and then I tend to your questions, that is if they are there. Oh, Meron, what happened? It's okay. Uh-huh. Meron is asking, how does stress lead to loss of weight? Okay, that is a good question. Uh-huh. How does stress lead to loss of weight? Anyway, we are seeing that if there is stress, now the question is which stress? The mind. Now, if there is a stress in mind, then the body responds by producing these these amine hormones, these these hormones from the adrenal medulla, and these hormones include number one, we have epinephrine, we saw it, we have norepinephrine and dopamine. Dopamine, it's dopamine hormone. It is also an amine derivative hormone. Now this dopamine, the body responds by producing, by secreting those hormones. And dopamine is a hormone responsible to elevate your moods. If you are angry, if you are sad, if you have stress, okay, then this hormone is released in large quantities to elevate your moods. Okay, the adrenaline is produced to elevate your moods, to make you active. Okay, and so the effect of these hormones is increased metabolism. Okay, and sometimes when you are stressed, usually don't take in enough food, but there is a reasonable increase in metabolic rate. Okay, and so if there is an increase in metabolic rate, but you are taking in less food, then there will be a negative energy balance. Okay, and so you reduce in size. Is that okay? Yes, I hope I've explained. Yes, in mind. Yeah. Uh-huh. The Gracious is asking, what is the difference between allergy and stress? Now, allergies, it is also an autoimmune disorder where your body overreacts towards something. Hmm? Your body overreacts. Like, you have a kid, this kid likes to play. But they are kids who overdo. They overdo it, exaggerate. So your body overreacts. For example, you might have allergies, maybe like you. Now I have my neighbor. Let me use him. Sorry for him if he's hearing. My neighbor, if he smells, if he senses a fume, if you use any fume, then the neighbor is going to sneeze, sneeze, like for the whole day. Now, that one is an over exaggeration. It might be a normal process, a normal thing that is helping an organism to cope up to stress, to cope up to a stressing environment. Okay, because when you stress maybe to this, when you get exposed maybe to particles such as spores, pollen grains, okay, the body might respond that you are in a stressing environment. But when you go away from such a stressing environment, then it should stop. But now this one, it does not stop. It continues until even the nose swells. Okay, so that one is an allergy. Okay, overdoing it, overreaction given by the body. But now stress, now this stress is anything that is infringing on the body's rights. Okay, I think you have used the right word. Anything that is it infringing or intruding? You can check your dictionary. On the body's right, it is stress. So if the body is supposed to go in this direction, and for you force it to go in this direction, then that is stress. Okay? Yes. Any other question? Please drop your question. Thyroid gland. No, I've answered. So anyway, you drop your question, I always find it. Now let me introduce you to some new concept. The renin angiotensin system and control of blood volumes. Yeah. The renin angiotensin aldosterone system of control of blood volume. Now, okay, now, so the aldosterone, we saw it, it is a steroid hormone that is produced in the adrenal cortex. Okay, and one of the functions is to regulate water in the body. Okay, and how does it do it? We are going to see. There is a relationship between sodium ions, okay, and water, in that if you have more sodium ions in blood, then you absorb more water in blood, okay, and so the blood volume increases. Okay, but if you reduce the sodium ions in blood, then the osmotic pressure or the osmotic potential of blood reduces compared to the surrounding cells, surrounding tissues. And so water is moved from blood into the intercellular space. Okay? So now if you want to regulate blood volumes, then you regulate the levels of sodium ions in blood. So the aldosterone, for example, it regulates water retention in the body by controlling the distribution of sodium ions and other minerals within blood as a tissue. Is that okay? Now, it increases the reabsorption of sodium ions and chloride ions by the kidney, and then loss of potassium ions in the urine. So if you absorb these sodium ions by the kidney, then you remove or you reduce the amount of sodium ions in blood. Okay? And so you are able to restore the volumes of blood back to normal. So this system works to regulate the blood volumes. Okay? And we are going to see the significance. We are going to see it. So how does it work? If there is a decrease in concentration of sodium ions, okay, in blood, then there is a decrease in sodium ions, so there will be a decrease in total volume of blood, because you have decreased sodium ions, so the osmotic potential of blood is going to decrease, and so water moves out, so the blood volume decreases. So that one is enough stimulus to be detected by special kidney cells called junctional glomerular apparatus. We are going to see them, don't worry. These special kidney cells, we are going to see them, don't worry. So it is enough to be detected. Now they are osmoreceptors. In these cells have osmoreceptors, okay? And so those osmoreceptors, they are the ones that are able to detect the volumes and the osmotic pressure of blood. And so when they detect that, then they will produce this hormone, renin. Now, that's why in digestion you were cautioned. The renin in digestion, it is R, then E, double N. Okay? Now, if you don't write this in digestion, we shall cross you. Now, the renin here, it is single N. But they are all renins. That's why you should take enough care. Now, when this renin is produced, it will be released into blood. Now, in blood, you have there a plasma protein called angiotensinogen. Okay? Now, this angiotensinogen, it is found in blood, but usually in an inactive form. And the inactive form is angiotensinogen. Now, this angiotensinogen in active form is activated by this renin into the active form called angiotensin. But if you want to be specific, then you can call it angiotensin 2, because this process occurs in two steps, where you first convert angiotensinogen into angiotensin 1, then you convert angiotensin 1 to angiotensin 2. But even if you write angiotensin, we shall give you. Now, it is a plasma protein, okay? But usually in an inactive form, angiotensinogen. So when it is activated to angiotensin 2, which is an active form, then it will be transported to the adrenal cortex, where it will stimulate cells in the adrenal cortex to release aldosterone hormone. Okay? Now the increased levels of aldosterone hormone, okay, in blood, they will stimulate the kidney to absorb more of potassium ions. So this causes the kidney to conserve both water and potassium ions. So you remember, after forming that glomerular filtrate, the potassium ions will be, yes, they will be, you have more potassium ions in the glomerular filtrate. And so this aldosterone hormone, it causes the kidney nephrons to absorb more of potassium ions from the glomerular filtrate. Sorry, sodium ions from the glomerular filtrate. And so if you absorb more of sodium ions from the glomerular filtrate, then water follows by osmosis. You should know the countercurrent multiplier effect, okay, in homeostasis, in excretion. And so if you conserve more sodium ions, if you absorb more sodium ions and you absorb more water, then the blood volume is going to be restored, okay, restored back to normal. So angiotensin also affects the center of the brain, okay. This angiotensin, which is going to saturate in blood, it also affects the brain, okay, to create that sensation of thirst. So you feel thirsty, and so when you feel thirsty, you take in more water. And when you take in more water, then the water is going to be absorbed, because remember, water is not digested. You take in, it's just absorbed, and the levels or the volumes of blood are restored back to normal. Now, overproduction of aldosterone often results into excessive sodium retention by the tissues, and so high blood pressure and headaches sometimes. So if you overproduce the sodium ions in the blood, then there will be high blood pressure. Much water is going to be absorbed in blood, high volumes, okay? And because of the high volume, then there will be high blood pressure, which is not good, okay? Everything must be maintained to normal levels. So this is basically what we are talking about, okay? So blood pressure or blood volume drops, for example, due to dehydration or blood loss. Mark this word, because I'm going to talk about it. Mark this word, okay? So this one is detected by the juxtaglomerular cells, okay, that make up the juxtaglomerular apparatus. So this is renal vein, okay? So the whole of this, it is the juxtaglomerular apparatus. So these cells, they are the ones that have osmoreceptors, okay, that are able to detect the decrease in pressure and volume of blood, okay. And so these cells, when they detect, then they become stimulated, and so they release this renin. It is a hormone, Okay, now this renin, it is going to activate the angiotensinogen that is produced in the liver. It is a plasma protein to always saturate within blood, but in an inactive form. So when this renin is released, then the renin is going to activate this angiotensinogen. It is an oligopolysaccharide. Find out what it means. So this angiotensinogen, now you can jump these steps. This is, if you want, you can talk about it. If you don't want, just say to angiotensin 2. Now this angiotensin 2, it will have an effect on the adrenal cortex, where it will stimulate the cells, okay, the adrenal cortex cells, to release aldosterone. Now the raise of aldosterone levels in blood, okay, it will induce, or it will stimulate more absorption of sodium ions and water, so increasing the blood volume, and so it was restored to normal levels. Now I want you to think about this, and I want you to read about it after here. This Raas, it is usually written as the renin angiotensin aldosterone system. This one helps you to know the order. Okay, it is renin first, then angiotensin, then aldosterone. Okay, and then aldosterone restores the normal levels. Now this system, we have seen that it has an impact on water absorption, okay, by the kidney, and so increasing blood levels. But also ADH hormone, okay, ADH hormone, which is a neurohormone, it also has an effect, okay, on water absorption, where this one increases the water absorption. And also this Raas system, this renin angiotensin aldosterone system, it also increases water absorption. Okay, now they can both work together. That is, if the water levels drop, if the volumes of blood drop, that means that the osmotic pressure is going to be high. So both ADH and this system is going to be activated. But now, remember I told you to mark this word. Okay? There is an instance where the blood levels drop, but water is enough in blood. For example, when you get an accident, God forbid, okay, you're going to lose blood, but the water levels, the normal levels of water is going to be the same, okay, but you're going to lose blood, and so the volume of blood is going to be down, yet the water levels are high. The water is enough, but the volume is low due to the loss of blood. Let me repeat it. So because of that, then there will be a need to elevate the volume, but not water. Are you seeing that? There is a need to elevate volume, but not water. So as a result, the ADH won't be released because the stimulus is the increase in osmotic pressure than normal. But in this case, the osmotic pressure is normal, but the volume has just decreased. And so as a result, you will activate the Raas system, this system. And so if you activate this system, then it will increase the volume of blood without tampering the concentration of water in blood. It is some interesting science, okay, that you should find. Try to read about it. You can recheck Campbell, okay, that book I gave you.